And today we're going to see robo bounded and circle problem. So in this problem, a robo is standing at 0, 0 position and it is facing north, and it receives three instructions. One is G, which means it goes straight 1 unit, and the other one is L, it means it turns left 90 degrees, and R turns 90 degrees to the right. And once it has received the instructions, all the inputs, we need to verify if the robo comes back to the original position 0, 0, or is it on the way to 0, 0. So what it means is it should not face north if it is coming on the way to 0, 0. So we should not verify that it either goes comes back to 0, 0, or it should not face north. So we need to verify two things. One is the direction where the robo is moving, and we need to verify the output final point where the robo is. These two are the outputs which we need to get. So to start with, we have a direction. Current direction is north, and we need to know if a robo moves from left to right from the directions. We need to know that. So we need to have a map, left map and right map for each directions. Okay, for example, right now the robo is north. So right now the robo is north, and if it is moving left, right, so that is your west. Okay, this is your east if it moves right. So let's note this down. So if from north, if it goes left, it's west, and if it goes right, it's east. Okay, similarly for south we would do it. So for south it would be east. If it goes right, it's the opposite, and it would be the west. Let's see why. So if it is moving, okay, let me erase this. Oh, come on. Okay, so let's assume that this south, it is right now in south. So if you're in south and you're moving, left would be east. So that's your east. And from south, if you're moving right, that's here, right? That's why we make this west. So that is the assumption which we got this map. Okay, now let's do the same thing for west and east direction. Okay, let's do it for west. And for east. So this is the only tricky point in this problem, to understand directions. So I'm trying my best here to explain you guys. So right now the arrow is pointing towards, it's pointing towards east. Okay, and from east your left would be north. And the right would be south. Similarly, your left would be south, and right would be north. So these are the main things we should know for this problem. And then we need to understand which point it moves towards, if it is going left and right. So if it is going left, if it is going north, it means x comma y is, y would be increased to +1. So I think I would better write it down. So it moves towards, so let's do this. The moment, if it moves north, it means your x-axis remains same and your y-axis moves to 1. Similarly, if it moves south, your x-axis remains same, which is 0, and it goes -1. Similarly, if it goes east, your x-axis will move towards 1 and your y will remain same. If it goes left, which is west, it becomes -1 and 0. So these are the main movements. It can move from 0, 0 if it is so north, south, east, or west. So these three things are very important to understand to go ahead with this problem. And next is a simple if loop. So for I instructions, if I equal to left, then the direction is would be your left of I, right? Your direction left of direction. Left of I, yeah, correct. So that would be that. So L, if your I equal to right, then your direction is right of I, right? Else your x-axis will move which direction it is. So you have to move, you have to make your x comma y is 0 comma 0, else your x would be movement of the direction, which direction it is currently, and 0, we need to add that to the point. So similarly y would be movement of direction in 1. So we would just do a print here to check we are doing good. So we would verify the direction in x-axis and y-axis, and then verify, we would return if x comma y equal to 0 comma 0 or direction not equal to n. So let's try. Direction reference before assignment, direction, yeah, spelling mistake. Okay, keyword L, direction is left of I, direction of, okay, what is the mistake? Okay, left of direction. Similarly, this should be right of direction, right? Yeah, so we are good. So what happens is if it is north, it is mode 1, 2, and then it goes left. So north left is nothing but W, so that's what we get. And from W left is south, so that's why it moved south. And then it moved towards the pivot point. From south it's just moving ahead, moving straight, and it goes back to 0 0. That's why it is 0 0. So let's check this scenario as well. So straightforward should be false, yes. and this will be verifying if it has moved from north, it should move to west. Yes, so let's uncomment it and submit. Yeah, it works. The only basic thing here which I tried to do is understanding where the left and right from each direction goes. If you get that point, it's pretty much easy. And movement is nothing. If you go north, your y-axis will go 1 point towards positive, and if it is s, your y-axis will go to the negative. If it is east, your x-axis will go 1 point towards the positive, and if it is west, your x-axis will go 1 point towards the left. So that is what the move does. Otherwise, it's a simple if else loop. So the concept is understanding this and understanding this. Thanks a lot, guys.